and equations topic. Chemical reactions subtopic 1. Reactants and products. Key points. Reactants. Substances that take part in a chemical reaction. Products. New substances formed after the chemical reaction. Chemical reactions involve breaking and rearranging of atoms, not changing the atoms themselves. Real example: in the burning of coke, carbon plus oxygen, carbon dioxide, carbon and oxygen is equal to reactants, carbon dioxide is equal to product. Simple trick. RP. Reactants change to products. Atoms don't vanish or appear, they just rearrange. Remember to learn. RAP is equal to reactants are participating, products are produced. Subtopic 2. Burning of magnesium in air. Key points. Magnesium reacts with oxygen to form magnesium oxide. The ribbon is cleaned before burning to remove any existing magnesium oxide layer. Bright dazzling light is equal to sign of chemical reaction. Reaction: magnesium plus oxygen, magnesium oxide. Real example: shiny magnesium ribbon burns with a bright white light forming white ash. MgO. Simple trick. Clean burn. Observe white powder. Clean the ribbon to make the reaction visible. Remember to learn. Mo is equal to magnesium plus oxygen is equal to MgO. Subtopic 3. Reaction between lead nitrate and potassium iodide. Key points. Mixing solutions of lead nitrate and potassium iodide forms a yellow precipitate of lead iodide. Indicates a new substance is equal to chemical reaction occurred. Reaction: lead nitrate plus potassium iodide, lead iodide, yellow, plus potassium nitrate. Real example: yellow solid seen when two misspelled colorless liquids are mixed. Simple trick. Mixed see yellow solid reaction done. Remember to learn. Lip is equal to lead iodide precipitate. Topic. Characteristics of chemical reactions. Subtopic. Observable characteristics of a chemical reaction. Key point. A chemical reaction shows clear changes. These are known as the characteristics of chemical reactions. Formation of a precipitate. Explanation: a solid substance, precipitate, forms when two solutions react. Example: lead nitrate plus potassium iodide, yellow precipitate of lead iodide. Simple trick. Mix two clear liquids, yellow solid appears is equal to reaction happened. Remember, PPT precipitate produces trouble. Solid, evolution of gas. Explanation: gas is released during the reaction. Examples: zinc plus HCl hydrogen gas, calcium carbonate plus HCl co-gas. Simple trick. Fizz or bubbles is equal to gas released is equal to chemical change. Remember, go zoom. Gas out is equal to reaction. Change in misspelled color. Explanation: the color of the substance changes during the reaction. Examples: iron rusts, gray to brown, lead nitrate plus potassium iodide, yellow color forms. Simple trick. New color appears is equal to new substance. Remember, cool red paint is equal to misspelled color. Reactions prove alteration. Change in state. Explanation: a solid may change to gas or liquid during the reaction. Examples: candle wax, solid, water vapor plus gases, petrol, liquid, burns gases. Simple trick. If solid gas or liquid gas is equal to chemical reaction, remember, S to G is equal to something's going on. Change in temperature explanation. A rise or fall in temperature is observed. Exothermic reaction. Heat is released, temperature rises. Example, zinc plus mist spelled sulfuric acid heat, beaker gets warm. B. Endothermic reaction. Heat is absorbed, temperature drops. Example, BaO plus mist spelled NH mist spelled Cl test tube becomes cold. Simple trick. Hot is equal to exothermic, cold is equal to endothermic. Remember, mist spelled exit heat is equal to mist spelled exothermic. Mist spelled enter heat is equal to mist spelled endothermic. Remember all 5 characteristics. PECTS. P. Precipitate. E. Evolution of gas. C. Change in mist spelled color. T. Change in temperature. S. Change in state. Topic. Chemical equations. Subtopic. What is a chemical equation? Key points. A chemical equation is a short way to represent a chemical reaction. Instead of writing long sentences like, zinc reacts with mist spelled sulfuric acid to form zinc sulfate and hydrogen gas, we write it in symbolic form to save time. 2 ways to represent a chemical reaction. Word equation. Reactants and products are written in words. Example, zinc plus mist spelled sulfuric acid, zinc sulfate plus hydrogen. Chemical equation. Symbols and formulae. Elements and compounds are represented using chemical symbols and formulas. Example, Zn plus H, so mist spelled ZnSO plus H. Rules for writing a chemical equation. Reactants on left side, LHs. Products on right side, RHs. Use plus sign to separate multiple reactants. Products. Use an arrow to show the direction of reaction from reactants to products. Simple trick to remember. LHs is equal to what goes in. Reactants is equal to reaction happens. RHs is equal to what comes out. Products. Remember to learn faster. WASP. W word equation. A arrow shows the reaction. S symbols and formulae used. P products on RHs. Topic. Chemical equations. Subtopic 1. Writing a chemical equation. Key points. Reactants are written on the left-hand side. LHs with a plus sign between them. Products are written on the right-hand side. RHs with a plus sign between them. An arrow points from reactants to products, showing the direction of the reaction. Simple trick. Think of it as a reaction sentence. Reactants plus reactants, products plus products. Example, Zn plus H, so mist spelled ZnSO plus H. Remember to learn. Rap is equal to reactants plus arrow products. Subtopic 2. Balanced and unbalanced equations. Key points. A balanced chemical equation has the same number of atoms of each element on both sides. This follows the law of conservation of mass. Steps to balance a chemical equation. Write word equation. Reactants plus products in words. Write skeleton equation using symbols formulas. Count the atoms of each element on both LHs and RHs. Choose the compound with the highest number of atoms to start balancing. Adjust the coefficients, numbers in front of formulas, to make atoms equal. Double-check all elements to ensure both sides are equal. Rewrite the final balanced equation. Example: unbalanced. Zn plus H, so misspelled ZnSO plus H, already balanced as atoms on both sides match. Simple trick to start balancing. Balance metals first, non-metals hydrogen, oxygen last. To learn steps: WWCCC bar, W write word equation, W write skeleton equation, C count atoms, C choose biggest compound, C change coefficients, B balance all elements, A arrow check direction, R rewrite final equation. Topic: balancing chemical equations. Subtopic: hit and trial method. Step by step. Key concept: balancing means making the number of atoms equal on both sides of the chemical equation. Example: reaction. Steam is passed over heated iron to form misspelled Fe, misspelled O, and hydrogen gas. Step by step explanation. Write word equation. Iron plus steam, magnetic oxide of iron plus hydrogen. Write skeletal chemical equation. Symbol form Fe plus HO, misspelled Fe, misspelled O plus H. List number of atoms on both sides. Fe 1, LHs 3, RHs, H 2, LHs 2, RHs, O 1, LHs 4, RHs. Start with the compound having most atoms. Misspelled Fe, misspelled O. Balance O by multiplying HO by 4 for HO. Balance Fe atoms. 3 Fe atoms on RHs, multiply Fe by 3 on LHs, 3 Fe. Balance H atoms. 4 HO gives 8 H atoms, RHs has only 2, multiply H by 4 for H. Final balanced equation: 3 Fe plus 4 HO, misspelled Fe, misspelled O plus 4 H. Simple trick: start with oxygen, then balance metals, and finally hydrogen. Always use whole numbers to balance atoms. Never change subscripts of formulas. Remember steps: WSLCFB, W word equation, S skeletal form, L list atoms, C choose compound with max atoms, F fix atom count by multiplication, B balance and write final equation. Topic: balanced chemical equation. Subtopic: implications of a balanced equation. Stoichiometry. Key concept: a balanced chemical equation helps us understand the quantitative relationships between reactants and products in terms of number of atoms, moles, mass, volume. For gases, this study is called stoichiometry. What information a balanced equation gives: number of molecules or atoms shows how many atoms or molecules are involved on each side. Mole ratio. Example: misspelled CaCO plus 2H close misspelled CaCl plus HO plus CO. 1 mole of misspelled CaCO reacts with 2 moles of HCl. Mass ratio: you can calculate actual mass involved using molecular masses. Misspelled e.g. 100 G misspelled CaCO plus 73 G HCl, 111 G misspelled CaCl plus 18 G HO plus 44 G CO. Volume ratio. For gases, at STP, 1 mole of any gas is equal to 22.4 L misspelled e.g., 1 mole of CO is equal to 22.4 L. Reaction helps calculate gas volumes easily. Example. Equation. Misspelled CaCO plus 2H close misspelled CaCl plus HO plus CO. 100 G misspelled CaCO reacts with 73 GHCl produces 111 G misspelled CaCl, 18 GHO, and 44 GCO. Volume of CO is equal to 22.4 L. Simple trick to understand. Use the balanced equation like a recipe, just like 2 cups flour plus 1 cup sugar 1 cake. In chemistry, 1 mole misspelled CaCO plus 2 moles HCl 1 mole misspelled CaCl plus 1 mole HO plus 1 mole CO. Remember implications. MMMV is equal to mole, mass, molecule, volume. M mole count, M mass ratio, M molecule numbers. V volume, for gases. Topic. Chemical reactions and equations. Subtopic 1. Limitations of a chemical equation and how to improve it. Key points. A simple chemical equation does not show the physical state of substances, whether heat is absorbed or released, the concentration of solutions, whether a gas or precipitate is formed. To make the equation more informative, physical state representation: solid, S, liquid, L, gas, G, aqueous, dissolved in water, misspelled AC. Example, Zn, S, plus H-SO, misspelled AC, misspelled ZnSO, misspelled AC, plus H, G. 2. Gas or precipitate formed. Use for gas, use for precipitate. Example, NH₄Cl, misspelled AC, plus misspelled AgNO, misspelled AC, AgCl plus misspelled NaNO, misspelled AC. 3. Concentration of acid. Dil. For dilute acid, conc. For concentrated acid. Example, Zn plus dil. H-SO misspelled ZnSO plus HCO plus conc. HNO-CO, no, plus no plus HO. All improvements. SPCG, S-state, S, L, G, misspelled AC. P precipitate, C concentration, dil.conc. G gas. Subtopic 2. Exothermic and endothermic reactions. Key concept. Exothermic. Heat is released. Reaction gets hot. Endothermic. Heat is absorbed. Reaction gets cold. Examples of exothermic reactions: burning of methane, CH plus 2O plus 2HO plus heat, respiration, in body CHO plus OCO plus HO plus energy, rotting of vegetables into compost. Examples of endothermic reactions: N plus O2 no, needs heat. Dissolution of substances like glucose, potassium nitrate, ammonium chloride. Lab test trick. If the solution cools down, it's endothermic. If the solution heats up, it's exothermic. Remember, exit misspelled enter. Exit is equal to exothermic, heat goes out. Misspelled enter is equal to endothermic, heat goes in. Topic. Thermochemical equations and reaction conditions. Subtopic 1. Balanced thermochemical equations. Key concept. A thermochemical equation is a balanced chemical equation that also shows heat changes, delta H, involved during the reaction. If heat is released, it is an exothermic reaction. Delta H is negative. If heat is absorbed, it is an endothermic reaction. Delta H is positive. Examples: H, G, plus a half O, G, HO, L, plus 285.8 kJ heat is released is equal to exothermic. C, graphite, plus O, G, Co, G, plus 393.5 kJ C, diamond, plus O, G, Co, G, plus 395.4 kJ. Different allotropes, graphite and diamond, release different heat. Simple trick. Thermochemical is equal to chemical plus heat. Remember, misspelled CHAM plus misspelled delta H is equal to misspelled thermoequation. If you see delta H or energy mentioned, it's a thermochemical equation. Subtopic 2. Conditions for a reaction. Key points. Some reactions need special conditions like high pressure, high temperature catalyst. These are written above below the arrow in the chemical equation. Example: N plus 3H2NH conditions, 200 atm pressure, 450 degrees C, iron catalyst. Catalyst definition: a catalyst speeds up a reaction without being used up in the process. Another example: Co plus 2HCHO, methanol. Catalyst, misspelled ZNO plus misspelled CR, misspelled O. Temperature and pressure mentioned over the arrow. Simple trick. Write conditions on top of the arrow, like a roof over the house of reaction. Remember conditions: P, T, C. P is equal to pressure, T is equal to temperature, C is equal to catalyst. Topic: Ionic equations and types of chemical reactions. Subtopic 1. Ionic equations. The ions that remain unchanged are called spectator ions. Example: given reaction, Zn, S, plus misspelled CoSO, misspelled AC, misspelled ZnSO, misspelled AC, plus Co, S. Ionic equation: Zn, S, plus Co superscript 2, misspelled AC, Zn superscript 2, misspelled AC, plus Co, S. So superscript 2 is cancelled from both sides. Key term: an equation that shows only ions molecules actually reacting is called an ionic equation. Remember steps. Write misspelled ionize, cancel, balance. Subtopic 2. Balancing ionic equations rule. Must satisfy both mass balance, atoms of elements equal on both sides, charge balance, total charges equal. Example: Co plus Ag, Co superscript 2 plus Ag. Balance charges. LHS, Ag has plus 1, RHS, Co superscript 2 is plus 2. So, multiply Ag by 2, balanced equation. Co plus 2Ag, Co superscript 2 plus 2Ag. Subtopic 3. Types of chemical reactions based on nature of chemical change. Reactions are classified as combination reaction, A plus B AB, e.g. C plus O CO, decomposition reaction, AB A plus B, e.g. 2HO 2H plus O, displacement reaction, A plus B C A C plus B, e.g. Zn plus misspelled CoSO misspelled ZnSO plus Co, double displacement reaction, AB plus CdAd plus Cb, e.g. misspelled AgNO plus NaCl AgCl plus misspelled NaNO, precipitation reaction, formation of insoluble solid, precipitate, e.g. misspelled BaCl plus misspelled Na misspelled so misspelled BaSO plus 2NaCl, neutralization reaction, acid plus base salt plus water, e.g. HCl plus NaCl plus HO, redox reaction, involves reduction and oxidation simultaneously, e.g. Zn plus Co superscript 2 Zn superscript 2 plus Co. Reaction types. CDDDPNR. Combination decomposition displacement double displacement precipitation neutralization redox. Topic. Combination reactions general form. A plus B AB. Types of combination reactions between two elements between two compounds. Between an element and a compound subtopic. Combination between two elements. Iron and sulfur reaction Fe, S, plus S, misspelled Fe S, iron plus sulfur iron, 2, misspelled sulfide. Hydrogen and chlorine reaction H, G, plus Cl, G, 2H close, G, reaction in presence of light. Other examples 2Na plus Cl 2NaClN plus 3H2NH. Subtopic. Combination between compounds example, from previous image CaO, quicklime, plus HOCa, O, slaked lime. Two compounds form a single compound. Remember types. EEC. Element plus element compound plus compound. Element plus compound key trick to teach. If one product only likely a combination reaction, often exothermic, releases heat, common in burning. Metal reactions, acid-base preparations. Topic. Decomposition reactions definition. A decomposition reaction is one where a single compound breaks down to give two or more simpler substances. General form. A plus B types of decomposition reactions. Thermal decomposition uses heat, electrolytic decomposition uses electricity. Photolytic decomposition uses light energy. Thermal decomposition reactions takes place by heating the compound. Examples. Enter table, 7/2, reaction description 2Pb, No, 2PbO plus 4 No plus O. Lead nitrate lead oxide plus brown No plus oxygen. Row 3 of 7 column 1 of 2. Misspelled CaCO plus Co limestone quicklime plus Co. 2Cl 2K close plus 3 or row 4 of 7 column 2 of 2. Potassium chlorate potassium chloride plus oxygen. Misspelled MnO catalyst. Row 5 of 7 column 1 of 2. Misspelled ZnCO misspelled ZnO plus Co zinc carbonate zinc oxide plus Co. 2Co. No. 2CoO plus 4 No plus O. Copper nitrate copper oxide plus brown No plus oxygen. 2 No plus O potassium nitrate potassium nitrite plus oxygen. Exit table. Photolytic decomposition reactions takes place in presence of light, usually UV. Examples. Enter table, 3/2, reaction description 2 high H plus I. Hydrogen iodide hydrogen plus iodine, UV light, 2HO plus O. Hydrogen peroxide water plus oxygen, in light. Exit table. Hydrogen peroxide is kept in dark bottles to prevent photolysis. Electrolytic decomposition reactions break down using electric current. Example. 2HO2H plus O, via electrolysis, used to extract sodium, misspelled aluminium from molten salts. Decomposition in real life. Biology. In the body, digestion is a decomposition process. Starch glucose, via enzymes, protein amino acids common features. All decomposition reactions are endothermic. They absorb energy in the form of heat, light, or electricity. Misspelled remember. Misspelled the PEP. T thermal decomposition. H heat causes breakdown. E electrolytic using electricity. P photolytic using light. E endothermic. P produces simpler substances. Topic: displacement reactions. Types of elements involved. More reactive metal displaces a less reactive metal from its salt solution. More reactive non-metal can displace a less reactive non-metal. Reactivity series. Activity series of metals. Metals are arranged in decreasing order of their reactivity. Top is equal to most reactive, e.g., potassium. Bottom is equal to least reactive, e.g., platinum. Hydrogen is used as a reference point. Metals above hydrogen can displace H from acids or water. Metals below hydrogen cannot displace hydrogen. Displacement reaction examples. Metal plus salt solution. Zn plus misspelled CoSO misspelled ZnSO plus Co. Zinc displaces copper. Metal plus acid. Mg plus 2H close misspelled MgCl plus H. Magnesium displaces hydrogen from acid. Non-metals. Halogens F, Cl, Br, I. Fluorine displaces chlorine, and so on. Trick to teach. Show test tube demonstrations using Zn plus misspelled CoSO solution. Use colored salt solutions to make reactions visually clear. Remember metal reactivity order. Please stop calling me a zebra, instead try learning how copper saves golden plates. Stands for potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen, copper, silver, gold, platinum. Topic: displacement reactions. Detailed examples and applications. Examples of displacement reactions. Example 1. Zinc displaces copper reaction. Zn, S, plus misspelled CoSO, misspelled Ac, misspelled ZnSO, misspelled Ac, plus Co, S. Zinc is more reactive than copper. Blue misspelled CoSO solution becomes colorless. Misspelled ZnSO. Reddish brown copper gets deposited. Note: if copper is dipped in zinc sulfate, no reaction. Example 2. Copper displaces silver reaction. Co, S, plus 2AgNO. Misspelled Ac, Co, No. Misspelled Ac, plus 2Ag, S. Copper displaces silver from silver nitrate. Silver forms white deposits on copper. Solution turns blue due to Co, No. Application in metallurgy. Displacement reactions are used to extract metals like silver and gold. Silver-gold ores are dissolved in misspelled NaCN, sodium cyanide. Zinc is added to displace silver-gold from the solution. Special notes. Exothermic nature. All displacement reactions release heat. Are exothermic. Example: iron added to misspelled CoSO, temperature rises. Type of reaction. These are also called single displacement reactions, because one element is replaced by another. Remember, Zinc can push soft gold. Zinc displaces copper. Copper displaces silver. Zinc can also displace gold. From cyanide solution. Topic: double displacement reactions. Condition for reaction: these occur between two ionic compounds in aqueous solution. The reactants must be soluble in water. A product is often insoluble and forms a precipitate. General reaction format: AB plus CD, AD plus CB. Two compounds switch their ions to form new compounds. Examples: Example 1. Barium chloride plus sodium sulfate, misspelled BaCl, misspelled AC, plus misspelled Na, misspelled So, misspelled AC, misspelled BaSO, white PPT, plus 2 NaCl, misspelled AC. Chloride and sulfate ions switch places. White precipitate of misspelled BaSO confirms the reaction. Example 2. Silver nitrate plus sodium chloride, misspelled AgNO, misspelled AC, plus NaCl, misspelled AC, AgCl, white PPT, plus misspelled NaNO, misspelled AC. Ag and Na switch anions. AgCl is insoluble and forms a white precipitate. Key observations: formation of a solid precipitate confirms the reaction. Double displacement means both cations and anions are exchanged. Remember, swap and settle. Swap ions are exchanged, settle precipitate forms. Topic: precipitation reactions. Key points: precipitation reactions form an insoluble solid precipitate when two aqueous solutions mix. Also occur when a gas is passed through a solution and an insoluble compound forms. Examples: barium chloride plus sodium sulfate, barium sulfate plus sodium chloride, white precipitate of misspelled BaSO, co-passed through lime water, calcium carbonate, milky PPT. Trick: mix two solutions, solid appears is equal to precipitation clears. Topic: neutralization reactions. Key points: acid plus base, salt plus water, also known as double displacement reactions. Examples: NaOH plus HCl, NaCl plus HO, NHO plus HCl, misspelled NH, misspelled Cl plus HO. Trick: acid plus base is equal to neutral phase. Topic: oxidation reduction reactions. Subtopic A. Definition of oxidation and reduction. Oxidation: gain of oxygen or loss of hydrogen. Reduction: gain of hydrogen or loss of oxygen. Remember, all Reg. All is equal to oxidation is loss of hydrogen, Reg is equal to reduction is gain of hydrogen. Subtopic B. Examples: oxidation of copper. Co. 2Co plus O2Co. Copper plus oxygen, copper oxide. Copper gains oxygen, oxidation, black substance, misspelled Co, forms. Reduction of copper oxide, misspelled Co, misspelled Co plus HCO plus HO, copper oxide plus hydrogen, copper plus water. Misspelled Co loses oxygen, reduction H gains oxygen, oxidation. Subtopic C. Redox reaction. Oxidation and reduction always occur together. If one substance is oxidized, another is reduced. Hence, such reactions are called redox reactions. Subtopic: oxidizing and reducing agents. Enter table 3 by 2. Agent type function row 2 of 3 column 1 of 2. Oxidizing agent. Gives oxygen or gains hydrogen. Helps in oxidation. Row 3 of 3 column 1 of 2. Reducing agent. Gives hydrogen or gains oxygen. Helps in reduction. Exit table trick to remember. Oxidizing agent. Adds oxygen agent of oxidation. Reducing agent. Removes oxygen agent of reduction. Topic 1. Ionic equations. What is an ionic equation? It shows only ions that actually participate in the reaction. Example, Zn plus misspelled CoSO misspelled ZnSO plus Co becomes Zn plus Co superscript 2 Zn superscript 2 plus Co. Balancing ionic equations balance both a. Number of atoms b. Charges on both sides. Misspelled e.g. Co plus 2Ag Co superscript 2 plus 2Ag. Remember, ion is equal to involved only necessary ions. Topic 2. Types of chemical reactions. Combination reaction. 2 or more reactants. 1 product. Types a. 2 elements compound b. 2 compounds compound c. Element plus compound. Example, 2 Mg plus O2 MgO decomposition reaction. 1 compound. 2 or more simpler substances. Thermal. Needs heat electrolytic. Needs electric current photolytic. Needs light. Example, 2 Pb. No. 2 PbO plus 4 No plus O. Remember, TEP. Thermal, electrolytic, photolytic displacement reaction. More reactive element displaces a less reactive one. Misspelled e.g. Zn plus misspelled CoSO misspelled ZnSO plus Co. Follows reactivity series. Remember, high kicks low, higher reactive kicks lower one out. Double displacement reaction. 2 compounds exchange ions. Misspelled e.g. misspelled BaCl plus misspelled Na misspelled So misspelled BaSO plus 2 NaCl. Precipitation reaction. Insoluble solid, PPT, forms from 2 solutions. Misspelled e.g. misspelled BaCl plus misspelled Na misspelled So misspelled BaSO, white PPT. Remember, double gives a solid. Neutralization reaction. Acid plus base. Salt plus water. Misspelled e.g. HCl plus NaCl plus HO. Special case of double displacement redox reactions. Oxidation reduction. Oxidation. Gain of oxygen or loss of hydrogen. Reduction. Loss of oxygen or gain of hydrogen. Misspelled e.g. Co plus O misspelled CoO. Oxidation. Misspelled CoO plus H Co plus HO. Reduction. Remember, all rig oxidation is loss, reduction is gain. Agents. Oxidizing agent gains electrons, gets reduced. Reducing agent loses electrons, gets oxidized. Misspelled e.g. misspelled ZNO plus CZN plus Co. Misspelled ZNO is equal to oxidizing agent, C is equal to reducing agent. Topic: Redox reactions, electron transfer. Subtopic 1. Understanding redox through electron flow. Oxidation is equal to loss of electrons. Reduction is equal to gain of electrons. Remember, all rig oxidation is loss, reduction is gain of electrons. Subtopic 2. Examples from the image reaction. Fe plus S misspelled Fe. Fe. Iron. Loses electrons. Oxidation S. Sulfur. Gains electrons. Reduction. Product. Iron misspelled sulfide. Fe superscript 2 S superscript 2. Trick. Metal loses non-metal gains ionic bond formed. 2. Reaction. Co plus I misspelled Co. Copper. loses electrons, becomes Co superscript 2 oxidation. Iodine, gains electrons, becomes 2I reduction. Trick. Group 17 elements, halogens, always gain electrons. 3. Reaction. H plus Cl2 H close. H. Hydrogen, loses electrons, oxidation. Cl. Chlorine, gains electrons, reduction. Trick. Hydrogen behaves like a metal in redox, loses electrons. Topic. Effects of oxidation in everyday life. Subtopic. Corrosion. Key concept. Corrosion is the slow destruction of metals due to the action of moisture, oxygen, and other gases. Definition. Corrosion is the process where metals are slowly eaten away by atmospheric gases like oxygen, carbon dioxide, water misspelled vapor, hydrogen misspelled sulfide, etc. Examples. Rusting of iron, formation of reddish-brown hydrated ferric oxide. Equation. 4 cap Fe plus 3 cap O sub 2 plus 6 cap H sub 2 cap O goes to 4 cap Fe cap O sub 3 dot X cap H sub 2 cap O. Tarnishing of silver, formation of black silver misspelled sulfide. Equation. 2 cap Ag plus cap H sub 2 cap S goes to cap A. G sub 2 cap S plus cap H sub 2. Subtopic. Rusting and its prevention. Why it's harmful. Weakens structures, bridges, iron rails, cars. Rust flakes off, exposing fresh metal to air and moisture. Methods to prevent rusting. Painting. Protective coating keeps air moisture away. Greasing, oiling used on machines, tools. Misspelled galvanization, coating with zinc layer. Using misspelled aluminium. Misspelled aluminium resists rust due to misspelled misspelled O layer, impermeable to moisture, air. Simple trick. RGP. To remember rust prevention. R rusts. G greasing. P painting. A misspelled aluminium usage. Topic. Effects of oxidation in everyday life. Subtopic. Rancidity. Definition. Rancidity is the oxidation of oils or fats in food resulting in bad taste and foul smell. Cause. It happens when food is kept for long and exposed to air, causing fats and oils to get oxidized. Examples. Spoiled chips, stale fried food, oily items left in open for days. Subtopic. Methods to prevent rancidity. Adding antioxidants. Substances like BHA and BHT are mixed with food to slow down oxidation. Vacuum packing. Air is removed from food packs to avoid contact with oxygen. Replacing air with nitrogen. Common in chips packets. Nitrogen gas prevents oxidation. Refrigeration. Low temperature slows down chemical changes like oxidation. Simple trick. Misspelled avery. To fight rancidity, antioxidants we vacuum packing. R replace air with nitrogen. R refrigerate.